Assalamualaikum warahmatullahi wabarakatuh. Saya Feni ingin membaca di bab integral di chapter 5. Di chapter 5, infinite and improper integrals, example 7.5.1. Define the areas under the graphs of a y is 1 divide x the power 2, b y is 1 divide the square root of x. The part 1, x is 1 to x is s, where s greater than 1. Point 2, x is r to x is 1, where 0 is less than r is less than 1. Ensure the function are a x the power minus 2 and b x the power minus 1 divide 2, so simplest integral are a minus x the power minus 1 is minus 1 divide x. Part 1, integral s1 1 divide x the power 2, the x is quantity minus 1 divide x cos quantity s, and 1 is 1 minus 1 divide x. Part 2-nya integral 1r r divide x the power 2 dx is quantity minus 1 divide x cos quantity 1, and r is 1 divide r minus 1. b 2x the power of divide 2 is to the square root of x. Part 1, integral s1 1 divide the square root of x dx. The x is quantity 2 the square root x quantity cos s, and 1 is 2 the square root s minus 2. Part 2, integral 1r 1 divide the square root x dx is quantity 2 the square root x quantity cos 1, and r is 2 minus 2 the square root r. The interesting feature of this result appears is if you consider what happens in I. If s becomes indefinitely large and in 2, if r comes indefinitely close to 0. Consider s first. By taking a large enough value for s, you can make 1 minus 1 divide s as close to 1 as you like, but it always remains less than 1. You can say that the integral a e tends to 1 as s tends to infinity. Quantitative written 1 as s tak terhingga quantity cos. A short then for this is integral infinity 1 divide x power 2 dx is 1. This is called an infinity integral. However, to the square root s minus 2 can be made as large as you like by taking a large enough value for s. So the integral bi tends to infinity as as s tends to infinity, or infinity as infinity. Since infinity is not a number, you cannot give a meaning to the symbol. Integral infinity 1 divide the square root x dx. In the case of r, the situation is reversed. The expansion 2 minus 2 the square root r tends to 2 as r tends to 0. So you can write integral 1 divide the square root x dx is 2. Even though the integral 1 divide the square root x is not defined when x is 0. This is called an improper integral. But in a 1 divide r minus 1 tends to infinity as r tends to 0. So you cannot give a meaning to the symbols. Integral 1 divide x the power 2 dx. You can see from the graphs that as you would expect, the case where the integrals are defined correspond the regions in which the graph is very close to one of the axes. You can then say the region has a finite area, even though it is unbounded.